In this video, we are going to talk about dividing square roots and also look at rationalizing the denominator. And what you need to know about rationalizing the denominator, because that is a new term, is that we are going to work with simplifying our radical expression or writing an equivalent expression where there's no radical in the denominator. So that's all rationalizing the denominator is, and we'll take a closer look at that, I think, in example 2. But let's start with just some of the dividing pieces. Okay, and I've got 3 quick steps to divide square roots, and I am going to look at first step, dividing the coefficients. So if I look at example 1, remember the coefficients are the numbers out in front of the radical. So I'm going to look at the 24 and 30 and see if I can divide or at least reduce those numbers. Now I'm recognizing that both those numbers can be divided by 6. So I'm going to go ahead and do that. So 24 divided by 6 is 4, and 30 divided by 6 is 5. Okay, now I'm looking at step 2 that says to divide the radicands if possible. So I'm going to look at the number underneath the square root sign, the 14 and 2, and if I can divide those, and I can, remember both of those are divisible by 2. So I'm going to go ahead and reduce that. 14 divided by 2 is 7, and 2 divided by 2 is 1. Now when I look at my final answer, I'm going to look at the radicals and see, can I break those down? Can I reduce anything? And I'm looking specifically at this square root of 1, I know is just 1. So on the bottom, I really have 5 times 1. Or a more simplified way to write that denominator would just be 5. So on the top, we're going to keep the 4 square root 7 all over 5 for your final answer. Okay, let's look at example 2. Example 2 is a good example to look at because notice I don't have any coefficients out in front to divide. That would have been step 1. And when I look at step 2, I'm going to look at those radicands. 12 and 5, I can't find a number that divides into both 12 and 5 at the same time. So this is a great example to look at where we will need to rationalize the denominator. Okay, we're going to use that process here on example 2. So step 1 couldn't do it, step 2 couldn't do it, so step 3 we're going to look at rationalizing the denominator. Okay, so I'm going to just rewrite the problem here. I'm going to start off with square root 12 over square root 5. That's just the original problem. So the rationalizing the denominator process actually involves multiplying. I'm going to take a look at my denominator, and it's the square root of 5. I am going to multiply by the square root of 5. And I'm going to do so on the top and the bottom. And the reason why I'm doing that, because really, square root of 5 over square root of 5, I'm looking at the part in green, that is equivalent to just 1. So I am multiplying my original problem by 1, so it shouldn't change the original value. Now what it will do is kind of change the appearance, because on top of my fraction, I'm going to multiply square root 12 and square root 5 to get square root 60. And on the bottom, square root 5 times square root 5, I'm going to get the square root of 25. Now before I circle that for my final answer, I'm going to look, can I break down the radicals? And I can. I'm going to break 60 down into 6 times 10, and 6 is 2 times 3, and 10 is 2 times 5. So I have a pair of 2's, so I am going to write that as 2 square root. Now the 3 and the 5 didn't pair up, so I am going to write that as 15 underneath the radical. And let me scroll and get a little more space here. Okay, so now on my denominator, the square root of 25 is just 5. So for a final answer, I have 2 square root 15 all over 5. Okay, so that process was called rationalizing the denominator. we're going to look for what you have in the denominator, and in this example we had a square root of 5, and you're going to multiply by that exact same thing, the square root of 5. The key is to remember to multiply the numerator and the denominator by that same thing. Okay, let's look at another example. I am going to slide over, look at example 3 for another dividing. And I like example 3 because it gives me a different take. Now I can start to reduce the radicand. I'm noticing the 98 and the 4, and that's one approach. But there's also another approach where I can break down that fraction and take the square root of the numerator, 98, and take the square root of the denominator, 4. And this might be a good way to look at your dividing problem, because when I look at the numerator, 98, I can break that down and pull out some pairs. Let me see, 98 I know is made up of 2 times 49, and 49 is 7 times 7. So on the numerator, I'm going to have a 7 on the outside with a 2 left underneath the radical. Now on the bottom, the square root of 4 I know is just 2. So in this case, by simplifying the numerator first and simplifying the denominator, I have a case where I have no more radicals in the denominator, and I don't need to rationalize the denominator. So that was kind of a nice trick, or a good look for, when you are dividing. If you notice, you can separate the fraction and reduce separately, and that may avoid any kind of dividing. Now I know this is my final answer because I'm looking at the coefficients, the 7 and 2 out in front. Those would not reduce. Okay, let me scroll back over, looking at number 4. See if I can make that a little bigger here. Okay, so I'm going to start off with that same approach. I am going to separate the fraction. I'm going to write that as 2w squared on top and the square root of 45x on the bottom. And I'm going to look to break this down first, see if I can pull out any pairs. And I know, at least on the top, the numerator, I can pull out a pair of w's. So I'm going to write that as w square root 2. Now on the bottom, I'm looking at that 45, because remember 45 breaks down into 5 times 9, and 9 has the pair of 3's. So I'm going to write that as 3, and then underneath the square root sign, I'll have the 5x. So in this case, reducing the numerator and reducing the denominator helped a little bit, but I'm noticing I still have a radical in my denominator, so I am going to need to use my process of rationalizing the denominator. So I want to take a look at what I have in the denominator, and I'm only going to look at the radical part. So I'm looking at the square root 5x, and that's what I'm going to multiply by. Now remember, I want to multiply on the top and the bottom. So really what I'm multiplying by, this part in green, is equivalent to just the number 1. So when we multiply, and I'm going to look at the numerator first, I'm going to multiply any coefficients, those parts out in front, numbers or variables, and in this case it's just a w. Now underneath the radical symbol, I'm going to multiply the 2 times 5x for 10x. Okay, on the denominator, I'm going to multiply 3, and there's no other coefficient, so I'm going to have just 3 in front of the radical sign. Now underneath the radical symbol, I am going to multiply the 5x times 5x for 25x squared. Now the nice thing about that 25x squared is that I'm looking at the 25 thinking, well, there's a pair of 5's, and I'm looking at the x squared thinking there's a pair of x's. So on the denominator, I originally have a 3 on the outside, and I'm going to bring the 5 out in front to join that, so 15, right? 3 times 5 is 15, and remember the x is paired up, so I'm going to have 15x out in front. Now the numerator stays as w, and then underneath the square root 10x. I can't break anything down. 10 is just made up of 2 times 5. So I'm going to look at my fraction one more time before I circle it and look if I can reduce. I'm looking at the coefficients out in front, the w and then the 15x. Nothing reduces there. Underneath the radical symbol, we said nothing reduces, so I am good to go. Circle it for that final answer. Okay. So the last example in this video is number 5. I think this is a great time to pause the video, and I want you to try number 5 on your own. Okay, I will give you a little hint or get started because I am looking at the second radical. Let me highlight that. I'm looking at that square root of 6 over 4, and that to me jumps out as a great opportunity to rewrite it as a square root 6 over square root 4. Okay, so I want you to start with that, and then once you've reduced that radical, bring in your multiplying with the first fraction, the x squared, square root 3 all over the square root of 5x. Okay, so I want you to pause the video right now. I want you to try example 5, and then we'll check back in a minute and see how you're doing. Okay, so pause the video right now. Okay, take a look at our final answer. We have a 3x square root 10x all over 10. If your answer had a few extra variables, take a look at my second to last step where I was actually able to reduce an x on the top and bottom. Thanks for watching.